This man is carrying a complete SSTR-1 outfit while preserving a perfectly normal appearance. The transmitter and receiver are under his coat in front, and the power supply is inside a loaf of bread in the package under his arm. The set is used the world over, so the power supply units are made in 3 types, necessary in a world with such widely varying electrical systems. Generally, a man needs only one kind of power supply, but the instructors in the classrooms show the student operators how all of the units work. This is the power supply that was concealed in the loaf of bread. It is designed for an alternating current of from 25 to 60 cycles and of 110 or 220 volts. The 110 and 220 are only approximate, as the unit will operate with as much as a 20-volt variation on either side of these markings, 90 to 130 volts on the 110-volt tap, and 200 to 240 volts on the 220-volt tap. The line voltage is easy to determine by looking at the voltage marked on an electric light globe. If there are no light globes around, push the voltage selector switch to 220 volts and turn the set on. If the set won't work or the tube will not light up, push the selector switch over to 110 volts. It won't hurt the set or blow a fuse if you plug into a 110-volt line with a switch set on 220 volts. If the tube doesn't light up on either voltage, the fuse under this cap has probably blown. Unscrew the fuse cap by turning it in the direction of the arrow, and take the fuse out to see if the link is broken. If it looks okay, your trouble is probably the tube. Try a new one from the spare parts kit, which always has a spare tube and a spare fuse in it. Should you run across a voltage outside these ranges, say 150 volts, try to operate with the selector on 220. If this doesn't work, go to the 110-volt tap, and providing the fuses don't blow, get the message out before the set burns up. On the power cord, the plug is the standard U.S. type. But because so many countries have a different kind of electrical outlet, you have an adapter plug that will fit into many of them. If neither of these plugs fit, you will have to rely on your own ingenuity to make a connection work. Sets that are going to be used where there is no commercial AC power get this second type of power supply. It works from any 6-volt storage battery or from dry cells, and has a rectifier tube and a vibrator to convert the battery current for use in the set. Attach these 2 clips to the battery terminals, making sure that the clip with the positive sign goes to the positive terminal, and the other clip to the negative terminal. The third type of power supply is a combination of the AC and the battery types just seen. In addition, it has a charging unit built into it, so a storage battery may be recharged when commercial power is available. A selector switch recessed into the lid will set it to operate from 110 or 220 volts AC current or from a 6-volt battery. The leads from the unit to the battery are 2 rubber-covered wires stowed in the bottom compartment. Put the positive clip that has the positive sign cut in it to the positive battery terminal and the negative clip to the negative terminal. When the power supply is being run from a battery, the selector is in the 6-volt position. But when the power supply is being used to charge the battery, the power cord is plugged into an outlet, and the selector goes on the charging side to the correct 220 or 110 volts. The transmitter or receiver is plugged into the 5-hole power socket, just like on the other two types. The AC part of the unit has a fuse holder for a 2 or 3 ampere fuse, which protects both the power and the charger circuits. Beside it is a second fuse holder with a 10 ampere fuse to protect the set when using a 6-volt battery. This rear view shows the regular rectifier tube that converts the AC current, and alongside of it, the vibrator that converts the battery current. This vibrator plugs into a socket almost like a tube, and if the fuses blow, it's a good idea to change the tube and the vibrator at the same time as you renew the fuses. If the fuses are okay, but the set won't work, changing the vibrator and the tube are the first things to try. By removing the lid on the front side, you can see the small battery charging unit that has been built in. A fully charged auto storage battery will run the outfit for about 10 hours before it needs recharging. But the small portable storage battery you will most often use will only operate the set for about 1 3/4 hours before it needs recharging. This charger works at such a low rate that the batteries must be recharged for 5 to 7 times as long as their period of operation. After learning about the 3 power supplies, the AC, the battery, and the combination type, the receiver and transmitter remain to be mastered. In common operating practice, our man would have the 3 units hooked together when sending or receiving. The transmitter plugged into the power supply and the receiver into the socket on the transmitter. The antenna for such a small room would be a simple wire strung along the wall, over a picture frame perhaps, bending it around the corners as you come to them. Then the transmitter is operated simply by pushing this switch to trans, or the receiver by pushing it to RCVR. But for study purposes, it is easier to take the units separately. This receiver is the first type made, but except for a modification of the tuning dial and the placement of the controls, all the models are the same. It can be operated alone by plugging its extension into the 5-hole socket of the power unit. For an antenna, any ordinary straight piece of wire of 25 feet or more can be used, and while a ground connection is not necessary, it may sometimes help. Only headphones are used with any of the TR-1s, and the phone plug goes in here behind the beat frequency oscillator switch marked BFO. The receiver tunes on 2 bands, one which covers from 2.7 to 6.6 megacycles with a white dot on the band selector switch thrown to the left. The other from 6.6 to 16 megacycles with a white dot thrown to the right. Set the band switch to the range which includes the frequency shown in the operation schedule. To find the frequency setting on the present tuning dial, which is graduated in degrees from 0 to 100, you'll have to consult the receiver tuning chart in the rear box lid. There is one chart for the 2.7 to 6.6 megacycle band, and another chart above it for the 6.6 to 16 megacycle band. For example, we wish to receive code signals on a frequency of 10.2 megacycles, which is on the 6 to 16 megacycle chart. Follow the line from the top of this square horizontally across the chart until it crosses the curved tuning line here. The vertical line running through this point we follow down to the base of the chart, where the degrees on the tuning dial are marked off. The number at this point is 60, the number to which we set the dial for the frequency of 10.2 megacycles. Turn on the power supply. Put on the headphones and adjust the volume knob to a comfortable level. Push the BFO switch toward the phone jack to turn on the beat frequency that will enable you to hear the code signals. Inasmuch as the signal frequency or dial setting may vary slightly, it is necessary to sweep a couple of divisions on each side of the number found on the dial calibration chart in order to locate the signal. Turn the dial slowly and with a light touch. Once the signal is tuned in, don't jar the receiver or push on the dial, as the receiver tuning may be thrown off. The BFO switch pushed away from the phone jack to the off position allows you to receive voice messages. This is seldom used, however, as the base stations always send their messages by CW signal, except in cases of rare emergency. The weak links in the receiver are certainly the tubes. If the receiver should quit working and you're sure the power supply is all right, the first thing to do is to install your replacement tubes when trying to get it back in operation. Each of the three models of the receiver has a different complement of tubes, which is not interchangeable. The sockets have the proper tube numbers marked beside them, and while the tubes themselves will fit into different ones, the sets won't work unless the sockets and their respective tubes have the same number. Experience in the field has also shown that set failure is sometimes due to one or more of the connections to the 5-hole female socket working loose. This happens after the 5-prong plugs from the receiver or transmitter have been put in and out of the socket a number of times. So much for your ears. The set is good, and you know how to listen. Now, you learn how to talk, to help destroy the enemy word by word. Over 1,000 miles, that's the range your news can travel. But due to the behavior of the frequencies used, there is a zone about 140 miles wide between the 15 and 150 mile distances where your signals may not be received. Plug the transmitter into the power supply the same way you did the receiver. The antenna is connected to the terminal having the white porcelain ring around it, and a wire from a good ground connection is attached to the other terminal marked GND. The crystal that controls the signal frequency goes into 2 of the many holes in this special socket. Where the receiver has 2 bands, the transmitter has 3. The ranges covered are from 3 to 5 megacycles with the switch over to the left, from 5 to 8 megacycles with the switch pointing straight up, and from 8 to 14 megacycles with the switch turned to the right. These are a few of the crystals for the frequencies you are to work on. They may all be within 1 band limit, or scattered through the 3 ranges, depending on your particular schedule of operations. They're marked in kilocycles instead of megacycles, but it's easy to convert kilocycles into megacycles. Simply divide the kilocycles by 1,000. Dividing by 1,000 is the same as moving the decimal point 3 figures to the left, and a crystal frequency of 6,180 kilocycles then becomes 6.180 megacycles. This crystal of 6,180 kilocycles, or 6.18 megacycles, plugs into its proper socket holes, and the band change switch goes in the 5 to 8 megacycle position, since 6.18 megacycles lies in the 5 to 8 megacycle range. The 7 holes in the crystal socket are there to accommodate the many kinds of pins found on the crystals made by different manufacturers. The 4 holes at the bottom are wired together to make a connection for one of the crystal pins. The other 3 holes at the top are also wired together to make the connection for the other pin. Plug the crystal in, 1 pin in the top group and the other pin in the bottom group, using only the holes that fit snugly around the pins. There's a trap here to look out for. Some crystals can be plugged crosswise into the socket, which is wrong. You can do it with the 2 small pins, putting them into this medium and this large hole. And the 2 medium pins can go crosswise too into this medium and this large hole. Doing this is the same as putting both pins in 1 hole. The crystal circuit is not completed and the set won't work. 1 pin must be in the top group and the other pin in the bottom. Don't forget. In common practice, the receiver, transmitter, and power supply are all hooked up together, and receiver operation only requires the switch to be thrown to the RCVR position. In this position, the transmitter antenna and ground are automatically connected to the receiver, thus saving you the time and trouble of rigging a separate receiver antenna. There are only a few points to running a transmitter. Put in the right crystal, tune the tank tuning knob, and adjust the antenna coupling switch. Of course, the band selector switch has to be on the right frequency, and the trans-receive switch pushed to trans. The strength of the signal for the antenna is regulated by the antenna coupling switch, and the passage of this strength into the antenna is made possible by adjusting the tank tuning knob to resonance. The antenna strength of the signal is shown by the brightness of the flashlight bulb or the deflection of the needle in the RF meter, whichever the set is equipped with. The brighter the bulb, or the more the needle is deflected, the stronger the signal. Many of the sets have the bulb built into them instead of the meter, because the bulb will stand more rough handling than the meter will, and give just as good an indication for operating purposes. However, after the bulb reaches a certain brightness, it's impossible to tell if further adjustments would make it any brighter. For this reason, a dimming knob for the bulb has been built into the set. Turn it to the right to full on position when starting to tune. And if the bulb becomes too bright, dim it down by turning this knob to the left, so the results of further adjustments can be seen. You can't send a message with the tank tuning knob at its brightest position, as the crystal may not follow all the key movements. It'd follow on the dashes, but some or all of the dots might be missing. Correct this by turning the tank tuning knob off slightly from the brightest bulb position. Work the key in normal dot and dash fashion and see if the bulb lights up at each keying. If it doesn't, recheck the tuning until it does light up at every operation of the key. When detuning slightly, you'll find that turning the knob in one direction will make the bulb go out almost instantly, but turning in the opposite direction will gradually dim it down. Always detune in the direction of gradual dimming. Now you're ready to send. Here's our man again, making a last check before tuning up. Dimming switch full on. Band switch on the 5 to 8 range. Crystal 618. Coupling switch to the left on number 1. Hold the key down and turn the tank tuning knob for brightest bulb. That's no good. The bulb won't even light. Try the next tap and tune the tank again. Well, the bulb lights, but it's very weak. Try the next one, number 3. Oh, too bright. Dim the bulb with the dimming switch and tune some more. That's it. There. Now the next tap. Tune the tank. That's better. That's brighter than 3. Maybe the next will be brighter yet. No, it's weaker. Back a point is best. Tune it up. Right, right, there. Now, detune a little bit. And try the key, dots and dashes. The bulb lights every time, not a single miss. We're ready to go. To send another bit of information back. The set has none of the refinements and luxuries of a larger modern radio with its complicated precision machinery. It has been cut down to the bare essentials. But the base stations that follow your schedules have a large amount of the finest, most powerful receiving and transmitting equipment that can be produced. And they have the personnel to back it up, to maintain 24-hour radio watches for weeks on end, listening for your signals, trying to contact you should circumstances disrupt the schedule you had planned upon. Their power, their number, and their personnel are all there for the one purpose of connecting you at all times to your operations base.